So let me continue with the data cleansing step where we just saw there was an issue with the data file. So let me bring it up. Here, apart from the missing value imputation, there can be a problem with the data where data comes in with lot of special characters. So sometimes the amount will be represented in dollars. It can be separated with commas, and sometimes some values can come in the form of percentages, or there can be email addresses where @ symbol is given, and in the URLs we have the colons, the slash, the backward slash and the forward slash. All such special characters might be part of the data that you work on. Now, how do we um, in order to work with the data, we have to ignore these values and clean it. So when we ignore these special characters, the data becomes clean and readable. If we have special characters and we read the data in R, it will treat that as it may just read any of these numeric attributes as character type attributes. So let us uh, read the data symbols, and okay, let me just clear this up for your view, and let me read the names. So we have the customer ID and sales percentage. Let us take a quick view. So we see here customer ID 1 to 9 and sales percentages. So we have some percentage values in the data. Now how do we get rid of it? So let us first see what is the structure of data. As I mentioned, so if you see the sales percentage, which is actually a numeric value, is read as a factor value in R. So that is the reason we have to ignore this special character and again read it back as a numeric value and not factor. So how do we do that is using the command gsub. So these are the substrings, or what do you call, the string manipulation commands in R, where it identifies the special character in the string. So as you see, once the character is available in the data, it is read as factor type or character type, and when such symbols occur in these variables, it will be able to identify and replace with a blank. So if you see sales percentage G sub, I am trying to replace percentage in the data with nothing. So I am just removing that in the symbols dollar sales percentage. So when we say symbols dollar percentage, we are calling only that particular column, sales percentage. So when I run this, you can see it has completed, and let us check again the string structure of symbols, and if you see, it has converted that as a character after removing the symbol. So for that reason we have to set it back to numeric. So how do we do that? We have just seen equal to as dot numeric of, and let us again see. So if you see, now it is converted into numeric type. So this is how we have to ensure that we get rid of the symbols and also the type conversion happens correctly. So if you have lot of punctuations in the data, we can straight away use this particular command, because in this data there was an example only with percentage, so this is the command. But however, if you find additional symbols in the data, this is how you can use the command. And you can please explore the gsub command. So if you say in help, so this is pattern matching and replacement, so you will find several variations of using this particular command, and there are some examples for you to work out as well. So how we can identify some of these texts and replace them. So this actually ends the data cleansing. Let me summarize at this point. What we have done is, we have once the data is integrated, we read the data, understand if there are any special characters in the data, get rid of them. We again typeset the attributes with the desired attribute type, and then use imputation methods to fill the missing values using central imputation or KNN imputation. Now let us understand what outlier means. Now the outlier in the data means any observation that is very different from the remaining observations that are recorded. So the formal definition given by Hawkins in 1980 is, an outlier is an observation which deviates so much from the other observations as to arouse suspicions that it was generated by a different mechanism. So some of the reasons why these outliers could occur is again similar to the reasons why there could be missing values. So it may be due to the difference in measurements. So it is like one of the manufacturing companies used to measure a particular product based on the volume, and now it started measuring based on the lot. So instead of measuring the count of products, they just started packaging it into lots and measuring into lots. So you can expect in some duration the number of products to be numeric, whereas number of lots to be just hardly less than 10. So there is a variation in the data. However, the overall, the system has not changed, but the measurement has changed. Similarly, if there can be some human errors, because of human errors there can be an introduction to the outliers in the data. Now if there is a breakdown of a particular sensor which keeps recording the readings of say temperature, and suddenly because of the breakdown for some duration there is no recording of the temperature. So the people on the floor, they just go and feed incorrect temperatures. So we can understand that such points can be understood as outliers. But statistically, how do we see if the data has outliers in them or not? So most general ways of identifying outlier is using scatter plots and box plots. So the basis for us to understand box plot is, we have to understand first what quartiles are. So in the previous session, in unit of in the same unit, day 6 and day 5, where we have worked out on the attributes how to compute the central measures, central tendencies, and compute the quartiles. So by quartile what we mean is the percentage split in the data. So when I ask for quartile 1, it means it is a 25th percentile split in the data. Similarly, the second quartile, which is Q2, is exactly half split of the data, and Q3 is 75th split of the data. So between the minimum and the maximum, we have three quartiles: Q1, Q2 and Q3. Now if I want to know the spread of the data, so one measure that we have studied is the variance or the range. Here in this case we can also compute the difference between the quartiles, which is called as interquartile range, which is Q3 minus Q1. And once we compute this, we can understand how far away or closer are the points with the quartiles or within the quartile range. Now let us see how the box plot looks like. So for a variable, once we plot the box plot, we have a box where the middle line is the Q2, which is the median value. The lower the lowest value is the minimum value. This is Q1, which is the 25th percentile, and third quartile, which is 75th percentile, and any value that is beyond the interquartile range and also exceeds the fences that we have computed here. If you see, the lower fence, the upper fence, where we compute based on the interquartile. So as you see, any point beyond this value is treated as an outlier. So let us quickly see in R how we identify outliers. So let me clear this up, read the stocks data. So this particular data, okay, let me also clear the history over here and come to stocks, read again. So if we see, there are about 320 stock values, and there are three variables. So we have weekly price of two different stocks, and we want to know if there are any outliers in the data. So this is again regular, we have to check this, and we see it is all numeric form, we are good with that. And when we say box plot of stock price 1, so this is how the box plot looks. So this is the minimum value, this is the maximum value, the middle line is the Q2, that is the median value, and the edges of the boxes are the Q2 and Q1 and Q3. And as you see in the data, there are quite a few outliers which are far away from the whiskers. So these are called the whiskers. So let us compute all the values. For the interquartile range, the function is IQR. For quantiles, as you know, it is quantile. And to compute the lower inner fence and upper inner fence, these are the formulae that we have just seen. Once we compute this, we get to know the values. So if you see, the upper outer fence is 539, whereas in the data we have values which are beyond 539. So let me see if we can retrieve those values here. I'm using the table name, which is stocks. Just like the way we have done the subsetting, I am just trying to retrieve those records exactly like this. To understand, so from stocks, what am I doing? I need stocks of price 1 where the value is greater than the upper outer fence, which has 539 as the value. And here it is. So you can see these are the three values which are beyond the upper outer fence. So this is how the subsetting will help. Now let us go back. There is a lot of confusion with regards to understanding what is an outlier and what is a noise. So the way we have to understand is any variation in the system other than the systematic variation can be treated as noise. So the incorrect values could be because of the faulty data collection instrument or data entry problems. So the problems seem similar. Why outliers or noise are introduced in the system or in the data, but we have to the ways to identify or categorize them is different. So we have seen using the interquartile range we can understand which if there are any observations or if there are any outliers in the data. Similarly, for noise we have a simple method called bin the data or partition the data and smooth it in order to understand if there is noise in the data. So let us see that. So the method is first sort the data, partition into equal bins, and then smooth based on either the means or bin boundaries. So let us take an example. Please hold on. I am just going to pause for a minute. So we have just mentioned two different ways of smoothing if there is any noise in the data. So let us take an example where we have the prices about 12 different prices. So we can partition that into equal sizes. Say bin 1 will have first 4 values and the next 4 values in bin 2 and so on. And the way we can smooth is using the two methods, that is either based on the average or the median and based on the range. So the first method based on the mean and median, mean or median. So if we see the average of 4, 8, 9, 15 is 9, so we just distribute everything with 9. So this is how we try to reduce if there is any sudden noise in the data by smoothing. So in the second bin, the average is 23, so we just substitute 23. So once we have this data, it is smoothed, and smoothed in sense there is no noise or reduced noise in the data. Similarly, we can substitute the bin boundaries. So it can be either, so in this case we have the minimum as 4 for bin 1, and bin 2 is 21, and bin 3 is 26. So we can substitute 4 for other values except the max value, so that we know there is a step involved. So we have 4 and then 15, and then there is 21 and then 25. So in this fashion we try to reduce if there is any noise in the data. So just few misconceptions that we have, just want to highlight those here. So distinguishing between the noise and outliers. So is noise always interesting, or is it desirable, or is it outliers that is interesting? So yes, definitely noise is not, whereas outliers it is. So if we take some of the application areas of identifying outliers, we have in banks, if we see, if some of the customers or one of the customers has a normal transaction throughout, and suddenly there is a lot of credit that he is seeking for, in that case we can understand that this particular activity is different from the regular activity, and highlight that as an outlier. So this is how the fraudulent cases in banks are identified. So outliers are not bad, but in some bad in sense, we have to understand the application area or domain in which outliers are important, and try to address that. So can noise objects be outliers? Yes. So uh, there is very thin line between the outliers and noise, so this can be, yes. Are noise objects always outliers? But yes, it is not always. Are outliers always noise objects? No. So can noise make a typical value into an usual one, or vice versa? Yes. So this is how we can understand the subtle differences between outlier and noise. So outliers, if they are there, based on the application area, we have to address the identify and address if it is important. If it is important, we have to treat that as a rare event or rare case. So just like we have system failures in a data center, so it is the data centers work towards maintaining and running of all the systems in the data centers, which is 99.99 percentage of time is it is up. So there are rare events, so sometimes there are breakdowns in the system. So these are rare events, but these are not outliers. So this is how we have to understand the outliers and noise. So let us just recap what we have completed in day 8 session. We have understood what pre-processing is and why it is important. Understand what steps are carried out in order to prepare the data or pre-process the data. Be able to read, merge, identify subsets, convert data types, and create dummies in R. Impute missing values using central imputation and KNN imputation methods, and understand outliers, and identify and compute in R how to identify outliers and noise in the data and how to correct them. So at this point I would like to um, review the projects that have been assigned to you all. So as I understand, there are three different data sets that have been shared with you, and if I am looking at the airfares data, where you can see there is lot of uh, information about the codes, the cities through which the flights have been traversing and all. So there is lot of missing information which is represented as stars, and there is other information like slash in the data. There are decimals, there are commas, there are dollars. So this data is perfect for us to carry out all that we have learned today. So reading, so just try to read this data, identify what are the special characters in the data, and get rid of them, and see if you can completely read the data, ignore the special characters, typeset the characters. So if once you remove the dollar value and comma value, it will still be read as a character value, so you have to typeset and convert it into a numeric value. So all the data cleansing step that we have learned today is very much applicable on airfares data. And let me also take a look at the get rich bank data, where we have part 1 and part 2. So the data is available in two data files, and if you see, the integration of these two data files is required. So you have to save this file part 1 as a separate CSV file, read part 2 in a separate CSV file, and just like we had the student ID as the primary key there, you need to take observation as the primary key and merge these two data tables to obtain a single file. And I don't see any other issue, but there are a lot of missing values here. So yes, so merging and handling missing values is applicable on this data. So yeah, the third data, which is about Toyota Corolla cars, and this data seems to be much more structured, and yeah, of course there are a lot of uh, ca categorical type attributes and as well as numeric type attributes. So you may have to read this data and understand if there are any missing values in the data, and if there are categorical attributes with several levels, then create dummies. And yeah, and then that's about the data pre-processing that one has to do on the three data sets that we have already shared with you. So apart from that, we have outlined the exercise uh, for today's lab session here. So we will share these files with you, and you will have to carry out these steps. So read the data of customer value and transaction and merge them. Read this file univcomp and create subsets where age is greater than 50 or income is greater than 70. Practice doing these, and once you are done with these, you can work on the project. So apply count if there are missing values, and record if there are missing values present, then apply central imputation and KNN imputation, and see if there are any outliers in individual attributes and so on. So that is how the first uh, uh, class on the data pre-processing uh, is about, and yeah, this is good enough for you to get started working on the projects. And if there are any questions, kindly post them on Piazza. We will be available. So thank you. I'll meet you in the next session, which is day 9, where we will be also reviewing additional pre-processing steps as part of like binning, standardization and normalization, and using some examples we'll work out in R how they are useful and their importance. So thank you.